Greetings, geometry students. This episode, perimeter of polygons. Pretty much the same thing we've been doing, except we're going to be using the Pythagorean theorem to find slants. So look at the first question. It says to find the perimeter of the figure. A perimeter basically is just the length around. This one's fairly basic because it's got 1, 2, 5 sides. All you do is just add those up. Perimeter of this figure, 8 plus 3.1 plus 2.5 plus 10 plus 5. Add all that up. You get 28.6. That's it. Look at the next one. Same thing. Just be careful. I've got this 10 plus this 10 plus this 10. This distance here is also 10, but I don't want that 3 because I have a little jog around. So I've got this plus that plus that. That's the only thing that's different. Perimeter of this figure is 10 plus 10 plus 10 plus the 7, the 5, and the 4. You don't want to add that 3 because that's not part of the perimeter. Total distance around this, 46. And I'm trying to find the length, so I'm going to include units. Does it get any harder? Look at number 3. Yes, it gets a little bit harder because now I don't have the actual numbers. For the flat sides, or the ones that are parallel, I'm going to just say 1, 2, 3, 4. This is not a perfectly regular polygon because this side is only 3, but that's 4, and that's 3. But I need to do the Pythagorean theorem to find this side here. I'm going to call this AB. Once I find it, it will be the same for this, this, this. So I'm going to count the blocks. This is 3 this way and 3 that way. So when I go to find AB, I'm going to use the Pythagorean theorem. I have a triangle that's 3 units and 3 units. I'm trying to find the hypotenuse. So I'm just going to say 3 squared plus 3 squared is equal to my hypotenuse squared, which I'm going to call AB squared. So that's 18. AB is equal to, I'm going to say the square root of 18. When you do that on your calculator, it's actually going to come to 3 times the square root of 2. I don't want to do that just yet. You can get a decimal approximation if you want, but I'm going to go straight to the perimeter. And I know the perimeter's got 4, 3, 4, 3. 4 plus 3, 4 plus 3. And then it's got 4 of these square roots of 18. So instead of adding those all in, I'm just going to say plus 4 square roots of 18. Now add that all up, and you get your total distance around. Decimal approximation, 30.97 units. You can go ahead and get a decimal approximation up here if you would like. That's about equal to 4.24. And then you could combine it into there, but it's just more accurate if you wait until you're finished to get the decimal. Look at number 4. Same thing. I've got a length down here. That's 9 units. Notice each of these is marked off in 2s. The rest of them I'm just going to have to use the Pythagorean theorem on. I'm going to start with AB. I have a triangle that I'm trying to find the hypotenuse. I don't know that length, but I do know the legs. You can either map it back down to the scale down on the bottom, or you can just say how far apart are 4 and 9. That's 5, that's 3. Somehow or another you're going to have to find the 5 and the 3. So when I go this AB, it's 5 squared plus 3 squared is equal to AB squared. AB is equal to the square root of 34. And the same thing on this one. I'm not going to get the decimal for that until I'm finished. Next, same thing, BC. I know this distance is 2, and this distance is 5. You can count back to the edge, or you can just say, what's the difference between 7 and 2? So, BC, 2 squared plus 5 squared is equal to BC squared. BC is equal to the square root of 29. Don't forget to take the square root. CD, that's the easy one. DA, excuse me. Well, I've got to do DA from here to here. This one's a little easier to see because I can actually count the blocks. 1, 2, 3, 4, 5, 6, 7, 8. And over here, 2. I'm going from 2 to 4. AD is 2 squared. Bah. 2 squared plus 8 squared is equal to DA squared. DA is equal to the square root of 68. Perimeter. You must do these separately. Do not combine them under a single radical. You must figure out these numbers separately. You must arrow out of your radical when you're putting it in your calculator. I actually do it this way. I say square root of 34 equals plus square root of 28 equals plus 9 equals plus square root of 68. It's just easier for me because I don't have to worry about arrowing out. 28.4 units. Nothing complicated about that. You just have to use the Pythagorean theorem or actually the distance formula. Look at next one. I skipped a couple. I like this one because this is kind of a challenge problem. It's actually kind of easy though. Challenge. If you look at, this is a triangle inscribed around or circumscribed around a circle. It may look kind of unusual, but this 12 is actually the same length as this. This is what I call a snow cone because it looks like a snow cone. If you have a circle and this length here is congruent to that length there. We'll learn that later in the year, but for right now I just have to take my word for it. That means this is congruent to that, and finally this is congruent to that. So I know if this is 12, this must also be 12. I know if this one is 10.5, this one must also be 10.5. But I don't know these orange ones, so the first thing I'm going to do is I'm going to say 21.6 minus the blue part, which is 10.5. And I've got 11.1. Well, if this one's 11.1, that means this one is 11.1. So for my perimeter, I've got a 12 and a 12, an 11.1 and another 11.1, a 10.5 and another 10.5, or if you prefer, add it all up and you get 67, I think, 67.2 units. And that's that.